So for your 5.07 quiz, you'll see that it focuses on geometric modeling, which is really just using geometric shapes to estimate the volumes, or it could be area. Mostly we're going to talk about volume in this section of real life objects. So here we have a drinking straw, and it says it has a circumference of 30 millimeters and a height of 210 millimeters. So a drinking straw it's going to be best modeled by a cylinder. And this is going to be an enlarged image of it so that you can get an idea of what it would look like. But it says it has a circumference of 30, so around that edge is 30 millimeters, and then it has a height of 210 millimeters. So if we want to know the best approximation for the amount of liquid it can hold, that's the volume. And the volume of a cylinder is pi times the radius squared times the height. Well, we know the height, but we don't know the radius. This is the circumference. And circumference is equal to pi times the diameter, or 2 pi r. And we're going to use 2 pi r because we want to find the radius so that we can use it in our volume formula. So we're going to set this circumference of 30 equal to 2 pi r. And we are going to take, and it says, let's see, it does not say to use 3.14 for pi, so we'll just divide by 2 pi on both sides. And so you'll put this in your calculator to get the radius. So take a minute to do that. And you should get, if we round it to 3 decimal places to the thousandths, we should get about 4.775 millimeters for the radius. So the radius is 4.775 millimeters, excuse me. So we're going to plug that in. Volume is equal to pi times the radius squared, so 4.775 squared times the height. So put that into your calculator. And you'll get a pretty large number. It's 15,042.357,959. So I'll keep going. It's about 15,042.358 if we rounded, and that would be in cubic millimeters. But again, we're just estimating here. So the closest estimate is going to be that 15,000. The next one says a community part is shaped like a trapezoid with a height of 30 yards. So let's sketch a trapezoid. Remember, that's got the 2 parallel bases and then 2 legs that are not parallel to each other. And it says it has a height of 30 yards. And remember, the height is not the legs, guys. It is a height that is sketched in. It's not actually a side of the trapezoid. And it forms a right angle with the bases. So just keep that in mind. So the height is 30. Top base is 25, bottom base is 33. And then the park has a circular fountain whose radius is 4 yards. So I'm going to sketch this in here. There's a fountain in here that's got a 4-yard radius. And we want to know the area of the park without the fountain. So what that means is we need to find the area of the park minus the area of the fountain. All right, so the park is a trapezoid. The area of a trapezoid is, hold on just a second, let me get rid of that. The area of a trapezoid is base 1 plus base 2 divided by 2 times the height. And there goes my pen being crazy on me. Let's try it this way. Divided by 2. Nope. It just wants to keep disappearing. Let's try that. There we go. So base 1 plus base 2 divided by 2 times the height is the area of the park minus the area of the fountain, which is pi r squared, because it's a circle. So let's plug in what we know. The 2 bases for the trapezoid are 25 and 33. We divide those by 2. So 25 plus 33 divided by 2 times the height of 30 minus pi, and it says use 3.14 for pi, so actually let's replace that. 3.14 times the radius, which is 4 squared. So all of this is going to go into your calculator, and you're going to take the first part and then subtract the second part. So you're going to take 25 plus 33 divided by 2, and you'll get 29 times 30. So the area of the whole park, without the, or including the fountain, is 870. But then the fountain itself is about 50.24 yards, square yards. So we have to take that away from 870, and you'll end up with about 819.76 square yards for what is left in the park without the fountain.